Precipitation hardening is a vital metallurgical process for aluminium alloys, incorporating specific solute elements like Cu, Mg, Si, Min, and Zn to enhance properties. In a state far from equilibrium, the alloy undergoes heat treatment, which causes solute atoms to cluster and form particles within the grain matrix, known as precipitation. As the alloy ages, the number and size of precipitate particles increase, ultimately providing resistance to plastic deformation, a key feature of precipitation hardening, also known as age hardening. Consider an aluminium alloy containing 4% Cu, initially at 550 C, where it forms a complete solid solution. This state is frozen during rapid cooling to create metastability. Metastability sets the stage for the alloy to harden over time. Heating to approximately 150 C accelerates the diffusion of copper atoms, enhancing the hardening process. The copper atoms cluster in local groups to form the Guigney-Preston zones, GP zones. The process is called precipitation, that is, the clusters of solute atoms, the GP zones, precipitate out from solid solution. Copper atoms cluster into Guigney-Preston zones, GP zones, precipitating out from the solid solution, contributing to the alloy's increasing strength. These GP zones exhibit a unique platelet shape, a result of smaller copper atoms distorting the aluminium matrix due to their clustering behavior. Aging curves illustrate different hardening rates: slow natural aging at room temperature, rapid hardening at elevated temperatures, and the resulting peak hardness variation. At a higher temperature, for example at 200 C, a lower peak hardness is reached quickly, and thereafter rapid softening occurs. The basic effects control the level of peak hardness are the alloy composition, the quench rate, the aging temperature. For Al-Mung-C alloy 6061, immediate aging post-quenching leads to rapid hardening, peaking at around 24 hours, showing the key effects of composition and processing. Age hardening can lead to underaging or overaging based on the timing, impacting the hardness and mechanical properties observed after various aging durations. Thank you for watching our video. Don't forget to like, comment, and subscribe for more informative content on aluminum alloys and materials science.